Let's continue our exploration of Pandas data frames by looking at our next little problem, which is how to sort this table of names by the length of the actual name. Now, here's a solution that looks fairly incomprehensible. This little monstrosity works, but it was developed in the spring 19 version of the course, and I will leave it to you to unpack how it works. It's a good exercise in understanding Python, but it's not the kind of sort of readable code that we encourage you to write. So instead, we're going to look at a couple of different approaches. The first one is to create a temporary column. This is a general pattern that is very useful in data frame manipulations, which is to add a new column to the data frame that has the information that we need, then to sort based on that column, and then we can delete it once we have a new data frame that has the structure we want. So in this case, we can use the string accessor to compute the length by simply calling the len method on it. Now, strings don't by default have a length method on them, but we can call len on the built-in Python len function on a string. So in Pandas, for convenience, it adds len as a method to the string accessor. So this operation will give us the lengths of these, and now we have that length as a series, which we can add as a new column to the data frame. So let's see what this looks like. Once we run this, we've added that series as we've appended it with the name lengths. So now for each of these words, we have the length of that field. And so now it is possible to call the sort values method saying, I want to sort based on this particular column right here. In this case, we want to sort in descending order so that we can take a look at the top names. And so here we have the names that have the longest names. And if you notice, they are all 15 characters long. So one thing that I'm curious about, and this is the kind of thing that is worth taking a look at, is checking actually whether any of those 15 names are actually whether any of those 15 character names look truncated to you, whether they look like they were clipped. And that doesn't seem to be the case in here. And the reason why I say that is because it is possible that the database system that they used had somewhere an arbitrary constraint that said, make that the name field is 15 long, and there's just no more space in their database for names, and they get clipped if they're any longer than that. That is a possibility, and it is something that this is the kind of thing where you should always look at your data to get a sense for whether the answers that you're getting back make sense or not. In this case, that doesn't seem to be the case. John Christopher is a full name. Francisco Javier is a common name in Spanish, and it's full. You notice that these are all composite names. So it seems like their database for composite names basically drops the spaces Francisco Javier, Maria de los Angeles, Ryan Christopher. Oh, wait a second. This one I think is clipped. So here's one name that in Spanish is Maria de los Angeles, most likely, not Maria de los Ángel. And so I suspect that there is actually a clipping effect happening here, and that Maria de los Ángel should be Maria de los Ángeles, but their database system has an arbitrary constraint of keeping name lengths up to 15. So this is the kind of thing that is worth investigating, because, for example, if you are connecting this to some other resource and you're using these names to do some lookups in some other database that has names, it's possible that the other one doesn't clip names, and therefore names that are longer than 15 characters would not be correctly matched. And so in this case, Maria de los Angeles might appear in some other table as a proper Maria de los Angeles. So even if you normalize by removing spaces and making them lowercase except for the first letter, you might still have a mismatch. So these are all questions you should always ask of your data when you're working with it. So now we can get rid of that column by using drop. Note that drop by default in Python, the drop method drops rows, not columns. So let's tap complete on it, and we'll see it is meant to drop specified labels from either rows or columns. And by default, it operates on rows. So the default is rows, which is the first dimension, so it's the 0th dimension. And you can also say, as the axis on which to operate, you can also tell Pandas to do it on the first axis, which is the columns or you can also say columns. So you could say axis equals columns or axis equals 1, and both of those have the same effect. So in this case, we're removing a column. So this could be equally done by saying, whoops. Interesting. Interestingly, it seems like, I'm surprised, there seems to have been a change in the API. No. This is a good error message to actually explain to you all what happened. Let's try to think for a moment what happened and why am I getting an error message, and then I will explain it. But I want to pause for a second and give you a chance to, you should pause the video, think about it for a second, and let's try to understand what happened. In here, we assigned baby names after dropping this column. We assigned it back to the variable baby names. So if I try to rerun this code once more, now the name lengths column is now gone. And so the error message that I am getting, that name lengths is not found in that axis along the column names, is actually true. So Pandas is giving me the correct information. So let's reconstruct this for a second so that we actually get it to work correctly. So in here, I can also say axis equals columns instead of axis equals 1, which may be a little bit more informative. In general, I prefer to use these kinds of terms, even if it's a little bit more verbose, rather than 0 and 1, because it's much more explicit when you read that. Like, yes, axis columns. Whereas if you see 0 and 1, you always have to think, well, 0, 1, how are they rows first? So even though it's important to know how to read that code, you should strive for writing your most readable code possible. Now that we have this little trick in our toolbox, let's use it to answer a different question. Let's suppose that we want to sort by the number of occurrences of the string dr plus the number of occurrences of the string ea. Now, that may sound a little bit arbitrary, but it's just an example for how to do a more complicated manipulation that doesn't rely on the fact that strings have a len, a built-in len function that works on them. So above, we build our new auxiliary column by explicitly calling len. What if we want to do something more complicated, like this new counting operation? So we can define a function that counts. So given a string, it'll count how many times does it have dr, how many times does it have ea, and add those numbers. That is exactly what we're looking for. And we can create that temporary column now by using the built-in map method of data frames and and series. Map says apply the function that you gave me to every element in this case in the name column. So let's take a, and once we have that, then we can sort by that new column. We've added our temporary column and we can sort by it. Let's take a look at what comes out. So now we see this is the column that counts how many dr and ea are available in a given name. So the DAndrea name has dr right here, ea at the end, and ea at the beginning, for a total of 3 occurrences of these two strings. So these are all names. Leandrea and DAndrea are all names that have that particular pair of substrings 3 times in them. Remember, this is the count of that name in that year. So in 1985, there were 6 kids named DAndrea. In 1988, there were 5, etc., etc. Now, one thing that now that we're talking about what is in that count name. Let's take a look at what that name series has. So it has 387,000 names, right? I'm sorry, I wanted to take a look at the count. The count has 387,000 rows. It's just another column in the same data frame. But interestingly, the maximum count is 8260. This is the most popular name in the entire database, not just in California, but I'm sorry, across all years. But the lowest number is 5. Think for a moment why that's the case. Are there really no names that appear less than 5 times? Are there no names that are so unique that there's only 1 or 2 babies named that year with that name? Parents all the time try to find very unique names for their children. It turns out that this is actually a property of the data set. For privacy reasons, the Social Security Administration removes names that appears less than 5 times, precisely because such a rare name might be a little bit too identifiable, and so for privacy reasons, those names are elided from the database. At least that is my understanding of the structure of this data set. But again, this is the kind of thing that you should always ask of your data, such as the clipping at length issue that we saw before. And these are things that should pop out whenever you're looking. This is why it's so important to look at your data and think about it for a minute, which is ask yourself, does it make sense? Is there anything weird about this field or that field? Do I expect to see that in my data, etc.? So now, now that we've done our job, we can get rid of our auxiliary column and drop it out. And we're back to the data frame that is sort of the way we wanted, but has no extra columns. Now, the second option is to generate an index. The second completely different approach, or not completely different, but related but different, that doesn't rely on adding a new column and modifying the data frame, is to produce an index that is sorted in the right order and use that index to effectively reread the data frame. So, because lock can accept an index as its value. And so we're going to start by basically scrambling, completely shuffling the rows. One simple way of doing that is to sample from the data frame, but to sample all of it. So the sample method takes as parameters how many items to return as n, and this is useful if you say I want to sample with 10 elements or 50 elements. But alternative, you can say how much of the axis to return. So you can't use both. It's one or the other. But by saying fraction equals 1, you mean 100%. So if you say sample from the data frame without replacement and sample all of it, effectively what you're saying is draw the entire data frame, but draw it at random, and you get a copy of the data frame that has been shuffled. So this is now an example of this particular data frame that has been completely shuffled. It has no particular order. Just to make sure that you're convinced, let's run this a few different times, and you see that every time we get the data in a different order, but we have all of the data. You could check that for yourself. And so now what we're going to do is to create a sequence of these lengths. Again, we do the same thing as before. We get this series that contains only the index value and the length of the name in its values. And now if we take this series of lengths and we sort it, we now have the index values. Remember, think about what happens with data frames. We said a data frame is a group of series that all share the same index. So we've made from the names, we've made a new series, which is the length of the names, but that series, obviously because it's pulled from the same data frame, it has the same index as every other series in the existing data frame. So if we now sort this particular series, it's still going to have the same data in the index. So the index in this length series that we have here is compatible with the data in the original one. So now what we can say is assign this index object as a variable. Remember, we can always access the index of a series itself, and then we can ask what happens if I get the baby names, but you give it to me accessed using the lock accessor by this particular index. So now what Pandas is going to do is going to go and read the elements from the data frame, but in the order that this index provides. And since this index contains the same data as the original index. It's just that the data is in a different order. This acts like a sorting operation. And so let's take a look at what happens. Here we go. We now have the baby names sorted by length, where in this case we didn't sort in descending order, so we have the short names at the top and the long names at the bottom. And in fact, Joe and TJ and Al are all 2-letter names, and those appear these many times. Let's double check that we get something that makes sense. If we look at the tail, we see our long names. These long names that we had seen at the beginning, they're right there at the bottom, which is consistent with having sorted in ascending order. And these operations that we've done in little pieces so that you see the construction of the solution, can be done all in one line. So here's an example of doing all of this. We say, grab the names, compute the length of the string, sort that one, and then grab the index of that resulting series and index using that into the main one. And let's take a look at the top, and here you go. In a single line of code, you've done it all. This isn't necessarily the most readable thing to do, and this can be hard to debug. If you're not getting the right answer, you're probably going to have to assign this into particular substructures. But sometimes it is handy. To write a little bit more concise code. Use your judgment. So we'll stop here. Before we move on to the next section, take a look at the code in here, play a little bit with it yourself, and please go over the quick checks before you move on to the next one.